Welcome to Algebra. We are doing Chapter 2, Section 7 today. And this is on consecutive integers. You're going to see word problems throughout the book where they work with consecutive integers. Consecutive integer, consecutive means next. So it's the next integer. And we get the next integer just by adding 1. For example, if we start out with 2, the next integer we'd add 1 would be 3, etc. So if we let n stand for whatever integer we're talking about, to get to the next one we add 1, to get to the next one we add 2. So if we started with 4, we would add 1, get 5, add 2 to the 4, we'd get 6, etc. You do have to know what the even integers are. They're all the even, positive, and negative numbers, and 0 is also even, and they're whole amounts. The odd integers they go on to infinity in both the directions of left and right. So it's all the negative odd integers and all the positive odd integers. If I talk about consecutive even integers, I'm asking you to find the next even number after the given one. So if I started out with 4, the next even integer you'd have to add 2, you'd get 6. The next one you would have to add 4 to the original number, you'd get 8, and so on. So they go up by 2. And it works with the same with the odd integers. So if I started out with 3, to get to the next one I would have to add 2. Get to the next one, add 2 more, or 4 to the first one, which is 7. So they go up by 2. Consecutive integers go up by 1. Even or odd integers go up by 2. And the next vocabulary check that goes with this section here will be multiplying fractions. So just a review for that, when you multiply fractions, you always want to have the simplest form of the answer ready to go. So you do canceling. So any numerator or denominator that shares a common factor, take out the largest or the greatest common factor. So 4 goes into 4 once and to 8 twice. 3 goes into 3 once and into 9 3. And then check. There's nothing else to do. The ones don't matter. So the answer is 1 times 2, which is 2. Over 1 times 3, which is 3. On the second example here, you can cancel any common factors. 5 goes into 5 once and into 10 twice. I can take out 4 goes into 4 once and into 28 7 times. 9 goes into 9 once and into 27 3. There's nothing left that's a common factor in the numerator or denominator, so multiply your numerators together. 1 times 2 times 1 is 2. 1 times 3 is 3, and 3 times 7 is 21. So our answer is 221. By canceling, you get the simplest form of the answer without having to simplify your answer when you finish. You need your notebook paper for your assignment. Check your heading. Math, room number, full name, full date. Skip a line. The assignment's page 72, written 1 to 55 odds, and 77 written 1 to 12 all. So we'll do the odds first on 72, so I'm going to do every other odd, and you're going to do the others. So number 1 on page 72. Copy the problem down. It's negative 37 times negative 2. We're multiplying. Remember, the signs are the same. We just add, if the answer is positive. The signs are different, it's negative. And if there's more than 2 factors, you count the number of negatives. So we have negative times negative is positive 74. You'll do 3 on the right side of the fold. We're on 5. We have negative 3 times negative 7 times negative 4. I have 1, 2, 3 negatives, so the answer is going to be negative. I have an odd number of negatives. 3 times 7 is 21. 21 times 4 is 84, so our answer is negative 84. Problem number 9. We have 5 times negative 3 times negative 10 times negative 2. I have 3 negatives, so I know my answer is going to be negative. 5 times 10 is 50, times 2 is 100, And 100 times 3 is 300, so my answer is negative 300. And I applied the commutative property and associated property to get that in my head. Number 13, I have negative 2a times negative 3b. Negative 2 times negative 3 is positive 6. And then keep your variables in alphabetical order A, B. Number 17, negative 7a times negative 5c. Negative 7 times negative 5 is positive 35ac. Problem 19, 21, got lost there for a second. 21, we have negative 7 times the quantity 3m plus 4n. This is a distributive property. Negative 7 times a positive 3 is negative 21m. And negative 7 times a positive 4 is negative 28n. Number 25, we have negative 1 times the quantity a plus b minus 3. So applying the distributive property, everything inside is multiplied by a negative 1. A negative 1 times a is negative a. A negative 1 times positive b is negative b. And a negative 1 times a negative 3 is positive 3. Number 29, negative 1 times the quantity negative x minus y plus 7. Again, the distributive property, negative 1 times the negative x is a positive x. Negative times negative. A negative 1 times the negative y is positive y. A negative 1 times a positive 7 is negative 7. It's actually the same as taking the opposite of everything inside. Number 33, you have 14p minus 7c minus 9c plus 11p. Remember, the sign of the number is directly in front of it. So I have positive 14p, positive 11p. That makes 25p. Here I have negative 7c and a negative 9c, which makes negative 16c. 37, negative 8x minus 7x minus 5x. They all have the variable x, so I can add the numbers in front. A negative 8 and a negative 7 make negative 15x, and a negative 5x makes negative 20x. Number 41, 88 times the negative 57 plus 13 times the negative 57 plus negative 1 times negative 57. This is where you need to recognize the distributive properties being used, and everything's being multiplied by a negative 57. So you pull that out. You are not going to use your calculator to multiply those. And in parentheses, take 88, going from left to right, plus 13, plus a negative 1. 88 plus 13 is 101. Take away 1 is 100. So we have negative 57 times 100, which is negative 5,700. 45. You have 7 minus 3 times the quantity r plus s. Using your distributive property, this is a negative 3 times r, gives you negative 3r. That's a negative 3 times a positive s, gives you negative 3s. And that's your answer. Because there's no like terms to add together. 49, you have negative 2 times the quantity 2q plus w minus 7 times the quantity w minus q. Distributive property, -2 times +2 is negative 4q. And -2 times a positive w is negative 2w. This is a -7 times w, which gives you a -7w. And a -7 times a -q gives you positive 7q. Collecting like terms, I have a -4q and a positive 7q, which makes 3q. And then a -2w and a -7w make -9w. And 53, you have 2 times the quantity, -7 times r plus 2s minus r, minus 3 times the quantity s plus 2r. Be careful of your signs. We're going to start inside the brackets because we have grouping symbols inside. We need to get rid of the -7 times the quantity. So -7 times r is -7r. And -7 times a positive 2s is -14s. Bring down the -r. I'm going to come over here and finish this part over here. -3 times s is -3s. And a -3 plus 2r is -6r. Going back inside the brackets, collecting like terms, I have a -7r and a -r, which makes -8r. Bring down the -14s. And then bring down the -3s and the -6r. Multiply by +2. 2 times -8r is -16r. 2 times -14 is -28s. Bring down the -3s, bring down the -6r. Collecting like terms, I have a -16r and a -6r. That makes -22r. Then I have a -28s and a -3s, which makes -31. On page 77, the problems with the consecutive integers, problem number 2, says the sum of 3 consecutive integers is 69. So you start by identifying your 3 unknowns, which are 3 consecutive integers. So x equals your first integer. And since it's just consecutive integers, we go up by 1. X plus 1 equals the second integer. And x plus 2 equals the third integer. And now we translate the problem, the sum of the 3, so it'd be x plus 1 plus x plus 2, those are the 3 integers, equals is 69. And there's your answer. You do have to identify your unknowns. Skip line number 4. It says the sum of 4 consecutive integers is -42. So x equals your first integer. X plus 1 equals your second. I go up by 1. X plus 2 equals the third. And x plus 3 equals the fourth. And it said the sum of the 4 is -42. So x plus 1 plus x plus 2 plus x plus 3 equals -42. Problem number 6. The sum of 3 consecutive odd integers is 147. Now we're working with odd integers, so x equals the first odd integer. And remember, odd integers go up by 2. So x plus 2 would represent the second odd integer. And x plus 4 equals the third odd integer. And it says the sum of the 3, so x plus 2 plus x plus 4 equals 147. Problem number 8, the product of 2 consecutive odd integers is 195. So x equals your first odd integer. And they're just talking the product of 2. So x plus 2 equals your second odd integer. It says the product of the two of them. So x times the quantity, x plus 2, that's the product of the two, is equals 195. Problem number 10, the greater of two consecutive even integers is 6 less than twice the smaller. So we're talking about two consecutive integers. So x equals the first even integer. Again, evens go up by 2, so x plus 2 equals the second even integer. And it says the greater of the two, which would have to be the x plus 2, is equals 6 less than twice the smaller. So take twice the smaller minus 6. And the last one, number 12, the smaller of two consecutive even integers is 5 more than half of the greater. So x equals the first even integer. And x plus 2 equals the second even integer. And it said the smaller of the two, which would be the x, is 5 more, 5 plus 1/2 of the greater. And in quantity, x plus 2. That concludes the problems for this section. Be sure to check your answers in the back of the book, and if you need help, please ask.